Okay, so the way that we do this is with something called the pinching theorem, which is the idea that if you can make a function that has some value that swings around and another function that has a value that swings around, then there's some function that you can prove is always smaller than this function and larger than this function, and you prove that the values of the top function and the bottom function, as they get to some point along the number line, so let's just say A, that these values converge to the same thing, then from that we know that the value of the middle function has to be that same thing as well, because it can only be it can only be, in the case of the lower function, larger than or equal to it, and in the case of the upper function, smaller than or equal to it. So the way that we set this up in our case is by initially looking at a function that's just theta, and we look at it in terms of other functions that can be constructed on the unit circle. So if we want to get something that's going to be smaller than theta, one way we can do it is we can just draw something out. So because we're going to be finding the limits of these things later, I'll just use both the positive and the negative case. So we can draw some line out to the edge, and then we can make this triangle. And we can make a function that's the area of this triangle. And the area of this triangle is going to be a half base times height. And a half base times height in this case is going to be a half of 1 times sine theta times a half. So it's going to be sine theta on 2. And if we want a function that's like this, then we can look at the area of this wedge. So going all the way out to here. And the area of this wedge is going to be theta over 2 pi times pi r squared. And r in this case is just 1. So it's theta pi over 2 pi. And that's just pi on 2. So for triangle, it's this. And we can see that this triangle is going to be smaller than this wedge. And then we want to see if we can make something that's bigger than the wedge. And it's this triangle, this right triangle that goes all the way out. And then this right triangle that goes all the way out is going to be a half base times height again. where the base is 1, and the height is going to be the side opposite theta over the side adjacent to theta. So what that'll be is tan theta, or another way of saying that is sine theta over cos theta. That's our wedge. And then this is our right triangle. So these are all being divided by half, so we can reconvert this into sine theta smaller than or equal to theta smaller than or equal to sine theta over cos theta. And then we can invert all of these. So flip all these fractions. Implicitly, this is sine theta over 1, and this is theta over 1. So make it 1 over sine theta is larger than 1 over theta is larger than cos theta over theta, over sine theta rather. And then from there we can multiply everything by sine theta. So sine theta over sine theta is just 1. And then we have sine theta over theta. And then we have sine theta over sine theta times cos theta, so just cos theta. And remember, we're trying to look for what happens when we take a limit of all this as theta goes to 0. And what happens when we take the limit as theta goes to 0 is that the 1 doesn't change. And we're just going to see what happens here, so we'll leave it as it is. And then cos theta, when theta is 0 from either side, is just going to be 0. It's just going to be 1 rather. So we see that the value of sine theta on theta as theta goes to 0 has to be between 1 and 1, or equal to 1 and 1, and the only situation where that can make sense is where it's equal to 1. So this therefore has to be equal to 1.